Hi, I'm Mike Mulvaney, Cropping Systems Specialist at the University of Florida, West Florida Research and Education Center. One of the most enjoyable parts of my job is meeting you face-to-face to talk about your production practices and answer your questions. Unfortunately, with COVID, I have to deliver this material online, but I hope next year that we can discuss these topics in person. With that said, today I'm going to talk a little bit about gypsum sources for peanut production. Hi, I'm Mike Mulvaney, Cropping Systems Specialist for the University of Florida, West Florida Research and Education Center. Today I'm going to talk about gypsum sources for peanut production. First, let's talk about why we need calcium for peanut. So you're probably already familiar with this, so we'll go quickly. You know that lack of calcium creates pops in our harvested peanut, which obviously reduces our peanut quality. It also affects our germination and vigor if we're growing peanut for seed. So calcium is very important for both quality and for seed quality. Calcium is xylem-mobile, so it can move up in the plant, but not phloem-mobile, so it doesn't move down the plant. And that means that calcium can't move to the pods where the calcium sink is really needed. That means, and the way the plant deals with this is that the calcium moves directly from the soil solution to the pod. Keep in mind that most of our calcium pod uptake occurs between 20 and 30 days after the peg enters the soil. So that means the timing of calcium application is critical. Also, we should be aware that larger peanut seeded types need more calcium than smaller seeded types. If your soil test calcium levels are less than 1,400 pounds of calcium per acre, Virginia types do respond. So let's talk a little bit about the sources of gypsum out there. There's phosphogypsum. Phosphogypsum is a waste byproduct from processing phosphorus fertilizers, and it uses phosphoric acid to create those phosphate fertilizers. Florida, by the way, produces 80% of the total phosphorus used in the United States, and it's also responsible for 25% of the global phosphorus supply. So this is a pretty ubiquitous source of gypsum available in this area. So phosphogypsum sources are slightly radioactive, which trigger certain EPA restrictions. Those restrictions indicate that gypsum that has 10 picocuries grams per gram of radium can be used as an agricultural amendment. If it's over 10 picocuries per gram, it cannot be used as an agricultural amendment. So phosphogypsum mined in North Florida is bumping right up on that limit of 10 picocuries per gram. The major phosphorus mines in Florida, in Central Florida, have an average of 26 picocuries per gram, and so that ends up not being able to be used as an agricultural amendment. And you can see we have large stacks of phosphogypsum that cannot be used and are essentially landfilled. So if we know that our limit in spreading 10 picocuries per gram for agricultural use is in effect on phosphogypsum sources, let's see what that equates to in terms of the real world. So in food, we can see bananas, carrots, white potatoes tend to have a total radioactivity of about 3 picocuries per gram. Lima beans are a little bit more. Brazil nuts are bumping up right against that 10 limit. Of course, there's not an EPA restriction on consumption of Brazil nuts, but this is just to put it in perspective about how much radiation we're actually talking about from using phosphogypsum in agricultural land. Another source of gypsum is flue gas desulfurized gypsum. That's Fgd gypsum. And this has become a lot more common of a gypsum source among our peanut producers. And every year I get more and more questions about gypsum sources and concerns about what those products may be and what they may contain and what it might mean for accumulation in soils. So let's talk a little bit about the source of Fgd gypsum. This is a byproduct of coal-fired power plants. And you can see here, this is sulfur deposition for between the years 2000 to 2002. And you can see we have large sulfur depositions occurring in many parts of the United States back a couple of decades ago. Now enter 2015 to 2017, and you can see our sulfur has been very much cleaned up. There's a lot less sulfur deposition due to the coal-fired power plants. Now, this is a good thing environmentally because it's limited acid rain deposition. What that means for growers, though, is that you're no longer getting your sulfur for free from the atmosphere. Now you have to include it in your agricultural production. And so where is that sulfur going? It's being scrubbed at the stacks of these power plants, and then what they do is they use that scrubbed sulfur as a source for gypsum. And so that's where this Fgd gypsum is coming from. So let's look at Fgd gypsum generation and use. So here we have in the blue lines generation, and you can see generation of Fgd gypsum has increased over recent decades, and so has Fgd use been generally increasing over recent years as well. So this is why I'm getting more and more questions about the supply of Fgd gypsum. Most of the questions that I get surround the accumulation of toxic metals. Let's look at modern Fgd versus old Fgd, and this is from a peer-reviewed publication published in 2019. And let's just take a look at what this new modern Fgd heavy element concentrations might look like. So if we look at arsenic, we've gone from about 75 milligrams per kilogram to about 2. Other one, you might be concerned about boron. Boron has also decreased from 145 to about 11. Calcium, obviously very high. So this is a good source of calcium in both old and modern Fgd gypsum. Other sources that we might be concerned about, mercury also has decreased. Another heavy metal that we might be concerned with is lead. And you can see old sources of Fgd gypsum have gone from about 11 down to 1.6 milligrams per kilogram. So you can see, generally speaking, we've seen a decrease in the heavy metal concentrations in modern Fgd gypsum compared to older Fgd gypsum sources. This is a publication from 2005 looking at Fgd gypsum as sulfur sources for alfalfa and soybean. And there's two different types of Fgd gypsum available. One is vermiculite and one is perlite. And the difference between those is the perlite and the vermiculite serve as carriers for the calcium hydroxide that's used as a sulfur scrubbing source. So it's basically a carrier that allows the sulfur to be scrubbed from the stacks. And so they've looked at both of these sources, both vermiculite and perlite Fgd. And these are the concentrations that are available or that are found in both these sources of Fgd compared to regular gypsum. So aluminum has increased, but we have high aluminosilicates in our soils in the south anyway. This is not a concern. I'm not concerned about aluminum. Our calcium has remained about the same, more or less, but let's go down to our trace elements. So let's look at lead again. So in regular gypsum, we're looking at about 99 milligrams per kilogram or 100 milligrams per kilogram, and we're about the same in both perlite and vermiculite Fgd. Other elements have increased though. So in regular gypsum, say our chromium concentrations have gone from 10 to about 30 or even 120 milligrams per kilogram. So there can be increases in some of these heavy element concentrations. And so I would invite you just to make sure that you get an analysis of your gypsum and keep on top of your soil testing if you're going to continually be applying this throughout the season or throughout the years. Just keep an eye. Here's another table showing other concentrations. So here's more flue gas desulfurized gypsum sources compared to commercial gypsum. This is another publication published in 2009. And this one is showing, let's see, our cadmium concentrations have not changed very much between this Fgd gypsum and commercial gypsum. Our lead concentrations have gone up about twofold. So these are things that we do want to keep an eye on if we're going to make repeated applications. And then, of course, there's mine gypsum, and this is the gypsum that you're used to seeing, and this is a lot of what's available in Florida as well. So what does it mean to use these at the field scale? So when we apply these sources of gypsum, how are they affecting our agricultural production? So this publication was from 2014, and they used 2 to 10 times the recommended rates of gypsum in this study. And at those rates, the authors concluded that the differences were not statistically significant except for mercury. And bioaccumulation in earthworms were statistically similar or lower than Fgd gypsum treatments. So I don't see a whole lot of earthworms in our fields regardless. We probably do enough tillage to scare them away or kill them. So this is something that, these authors are basically saying that there was not a statistically different accumulation between the two sources, regular gypsum and Fgd gypsum, in agricultural soils, except for mercury when applied at 2 to 10 times the recommended rates. The authors go on to conclude that Fgd gypsum can be used as a crop management tool to increase yields while at the same time safeguarding the environment. And why do they say safeguarding the environment? It's because otherwise this Fgd gypsum would have to be landfilled. Here's a continuation or a similar study on Fgd gypsum products as sulfur sources for both alfalfa and soybean. Here we are looking at the dry weight of alfalfa. And you can see, and these are various locations at 2 different years. And here's the control without any gypsum applied. Here's vermiculite gypsum. Here's perlite Fgd gypsum. And here's regular commercial gypsum. And the dry weights, you can see where there's no number, no letters behind these averages, there are no statistically significant differences. Generally speaking, there are no differences in the dry weight at most of these sites for any of the gypsum sources. Sometimes we can pick up a difference between the control where no gypsum was applied, but when we applied any gypsum, there were no statistical differences in alfalfa dry matter production. So let's look at the accumulation of toxic nutrients in alfalfa. Now I know this isn't peanut, but peanut studies are far and few between, so that's why we have to go to other crops to get an idea of how biomass accumulation or micronutrient accumulation might occur. This is just an indication of what we might expect in peanut, but the research hasn't been done. So in this case, we can see that, again, we've got our control with no gypsum applied, vermiculate Fgd, perlite Fgd, and regular gypsum. And we've got them at several different rates. We've got 16 and 67. The perlite Fgd gypsum was only applied at 1 rate. Regardless, you can see here that there are no statistical differences between any of these nutrient accumulations in alfalfa with the application at either rate between either of these sources and gypsum. So there's not any difference in the heavy element concentrations in the biomass of alfalfa using any of these sources. And here we're going to look at, same study, we're looking at the effect on yield of soybean in this case at various application rates. We've got, again, the control, we've got the vermiculite Fgd, perlite gypsum, perlite Fgd, and regular gypsum, and then we've got 2 different sites as well. And again, there are no statistical differences between any of the yields of soybean using any of these products at any of the rates. So again, these were not affected by gypsum source or rate. Those authors conclude that Fgd products are good sources of sulfur for improving the growth of alfalfa and soybean, and that Fgd products did not increase the concentrations of potentially toxic metals. So again, this isn't peanut, but we are talking about soybean. It is a legume, so we're going to use that as a model crop to inform our decisions. Looking at another study, looking at Fgd gypsum in the northern Great Plains. This study is interesting because the application rates that they used are equivalent to 750 tons of Fgd gypsum per acre. I don't know anyone who would ever apply that much gypsum to a field. Okay, usually we're talking about a ton, half a ton, somewhere in that range of gypsum per acre. So this is well above normal application rates. And so these authors are stating that some studies have shown that plant tissues do not become elevated with heavy metals with these high rates. But other studies do show accumulation of some of these heavy metals in other tissues. So that's what they're after here. What they end up doing at the end of their study at that high application rate is these authors conclude that Fgd gypsum can be an important amendment if the public becomes aware of its potential uses. So they further state that although the potential of Fgd is evident, there's a lack of a distribution network. So we don't have the infrastructure to move this Fgd gypsum throughout the country so that it can become available for application on fields. So these authors are not discouraging the use of Fgd gypsum. In fact, they appear to be proponents of using Fgd gypsum for agricultural production. So let's look at some other sources that were conducted more closely to home. So here was a study that was, this was actually PhD work conducted at Auburn University. This was published, the PhD was finished in 2015. And what they did is they looked at several sources. So they looked at Agrical, which is an Fgd gypsum. They looked at phosphogypsum, and they also looked at ordinary mined gypsum. And so here's our yield on Georgia Greener and also on Georgia 06Gs. And we've got a control, we've got the Fgd gypsum, we have our phosphogypsum source, and then we have our mined gypsum source. And then we also have a couple of different rates. They've also included regular lime as a calcium source in this experiment as well. And if we look at Georgia Greener, generally speaking, there was not a response for Georgia Greener among any of these treatments. You can see the control is statistically the same as any of these sources. So the Georgia Greener variety in this particular case at Wiregrass in 2012 didn't show much of a response. Now Georgia 06G, however, did show somewhat of a response. So the control at least came in with a lower yield. So we do know that we had a response to source of gypsum in peanut yield for 06Gs at Wiregrass in 2012. And in that case, interestingly, lime at the high rate ended up having the statistically highest yield. It was the same as the Fgd gypsum at the same rate. And then at these lower rates, there was no difference among any of these gypsum sources at this lower rate. So again, it doesn't seem to be that the source of gypsum that you're using is making any difference in peanut yield. So here's a continuation of that research. And here we're looking at the yield of peanut. This is 06G and Georgia Greener cultivars. And these are yields combined because there was a lack of cultivar by treatment interaction. And you can see these all have A's next to them. What that means is that there was no statistical difference in the yield between any of these sources. In fact, there was no difference between the control either. So that means that this site probably had sufficient soil calcium already available. And previous research by Glenn Harris at UGA has shown that our runner type varieties will not generally respond to calcium if our soil test calcium levels are at 500 pounds of calcium per acre. And so I would bet that this site had sufficient soil calcium that we did not get a response due to any amendment of and using any gypsum source or using gypsum at all. And let's look at some other factors that we might be concerned about. Yield is one thing, but we also have to be worried about our yield, our quality of our peanut. So here's total sound mature kernels at the wiregrass station in 2012, and then across several stations in 2013. You can see that we've got several different rates. We have a high rate here, and then we've got lower rates here. So you can see for total mature kernels or sound mature kernels, there was not much of a difference between the control and Agrical, which is our Fgd gypsum, or our phospho gypsum at the lower rates that we used here. However, using mined gypsum, we did end up with quite a large difference in sound mature kernels. That's only one site year. Let's look at our other site years. This site year, didn't matter what you did, didn't matter even if you applied any gypsum source at all. There was no difference in sound mature kernels. Same thing at this site year, no difference at all, even if you use or don't use gypsum at that application. So again, that probably speaks to background soil calcium levels. Now, at this site, there were some statistical differences, but they were all fairly similar, and there wasn't any general trend that we're seeing here. So generally speaking, it looks like there's a 50-50 chance that some of these sources might affect sound mature kernels, but we're not seeing a consistent response among any of these sources or even trends in any of these sources in terms of sound mature kernels. So to summarize our existing gypsum recommendations. So if your soil tests show more than 500 pounds of calcium per acre, and if your soil test lab is giving you results in ppm, that's the equivalent of 250 ppm calcium. So if your soil tests are showing greater than 500 pounds of calcium per acre, and your calcium to potassium ratio is greater than 3:1, you shouldn't necessarily expect a response to gypsum. What does that mean for you? That means sometimes seems like every other year we tend to be getting rained out when we want to apply our gypsum. In those cases, what I would do is I would target those fields that have less than 500 pounds of calcium and try to get your gypsum out on those fields first. And if you get rained out, then the other fields may have sufficient soil calcium that you may not expect a response to gypsum application. Now, if you've got a pivot, you can go ahead and apply calcium chloride through the pivot. But if you're rain-fed, you really don't have much option but just to go ahead and spread and then wait for the rain to water it in. So with the 500-pound calcium stated, if your soil tests are 500 pounds calcium per acre or greater, you're not necessarily going to expect a response. That's fine, but if you're growing runner peanut for seed, you have to apply at least 1,000 pounds of gypsum per acre, regardless of your soil test levels. And that's critically important for our seed industry. Remember what I said at the beginning. The calcium is especially important for germination and vigor of seed peanut. If we hold back those gypsum applications just because we don't think we're going to get a response, we can still affect our seed germination and vigor for the seed that we're offering to our peanut growers the next year. So please, if you're a seed peanut producer, make sure that you're applying your gypsum as required by the contract. Now, Virginia types, being a larger type seed, often require more gypsum and might be up to a ton per acre. And also, of course, we know that it takes about 20 days for 20 days after the peg enters the soil to take up calcium. So timing of application is critical. So do make sure you make your timely applications. Generally, we're recommending 45 days after planting to apply your gypsum. There seems to be a movement more towards recommending 30 days after planting. So We're looking 30 to 45 days after planting is really when we want to get our gypsum applied. And with that, I'd like to thank you for your time. Again, I really look forward to seeing you next year in person. And in the meantime, if you have any questions, you can email me, or you're always welcome to follow me at The Dirt Dude on Twitter. Thank you very much for your attention, and stay safe and stay healthy. Have a productive season.